الذكاء الاصطناعي يغزو عالمنا الحالي بجميع أشكاله. يغير قواعد اللعبة. اقتحم عالم الرياضة دون استئذان، وأصبح أداة من الصعب الاستغناء عنها، خاصة للرياضيين. ومعنا دكتور بول جريمشو بيكشف لنا عن تقنيات جديدة وحديثة ومتطورة ودقيقة جدا الرياضيين ما لهم غنى عنها. So it's really like fascinating. This is the word.
I can bring that down, put cameras on it, and film the person on that treadmill running or walking, and then turn them into a computer model, like what's on the screen behind me. And then you can analyze their forces, their running, their running style, every full body. Yeah. It's an instrumented treadmill, all right? So it's measuring, it uses pressure mapping underneath that belt to measure your foot pressure and foot position. So it can measure things like stride length, step width, number of cadences per minute, pressure per foot contact. So whether you hit on the outside of your foot or the inside of your foot, it can tell you the forces that are going through it. It calculates the forces, and it can show you, your feet out or feet in position. Okay. And this thing can do a number of exercise modes, a number of test modes. You can walk uphill 15 degrees. You can run at 25 kilometers an hour on it. Wow. You can reverse the belt and walk or run downhill. And if you were somebody who had like Parkinson's disease or, something like that, a motor control problem, we could put a harness on you and it could stop you from falling off it. It tells you basically how good these shoes are as well, for preventing shock, preventing load, pressure.
I feel a lot of vibration on my feet.
So this is the runner, front view. You see here he's hitting the ground with his right foot. That's his right foot position on the treadmill. So it's showing you different levels of pressure basically. So if you see red, it'll be higher pressure than blue, than green, and so on. This is where percentage of pressure, forefoot and back foot loading. And you can kind of tell him what's his stride, his running style.
So it should be followed by a specialist?
Yes, definitely. This is expensive and it's very accurate. This is a child walking.
Okay, and these are the infrared cameras?
Yes, that's right. Look, so you can move that around and see the child from different angles and different positions. So I've got 12 infrared cameras around this space, what you're standing in.
And what insights does it give us?
Well, this technology is extremely expensive and very, very accurate. So this technology is sub-millimeter accuracy and sub-degree. So we can tell the person the angles, the velocities, the accelerations, the center of gravity movement, all these different variables. We even can integrate it with that force plate and measure force as well. This is a full body analysis.
Full body analysis.
Yeah.
Wow.
And this is what was used to make the Avatar movie. And this has got a little bit of AI in it because the program can look at left and right legs, and it can say you have this deviation between your left leg and your right leg, and it shouldn't be this much, it should be this much. All these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 380 maximum frames per second, just as naturally as you can. All right, well, Farah, because we want to try and minimize that first peak and maximize the second peak. Here, This is okay because it's, what's her body weight? 600. It's below your body weight. So some people may have 2-3 times body weight going through their legs. And here you can use shoes, test different shoes to try and get that force down. This is you braking, this is a braking force, and the blue going that way is a push-off. And this green one tells me how much you roll inwards and outwards, and I can tell whether or not that was your right or left foot from that trace easily.
Upon that analytics, can I improve my...
Yeah, we could do many trials and we could say, oh Farah, this trace is improving, you need to walk like this, or we can try different shoes, you should be using this shoe, and we can change your gait basically to make it better. So she's putting one on the bicep femoris muscle. Yep. And she's going to put one on tricep. So she's got triceps and bicep. And this is electromyography. So this is measuring muscle activity. So when I contract my muscles, you'll see on the screen some activity. We could put these things on me and I could go walking or running or whatever, and I can do it 50 meters away from this station, and then it'll be recorded on there. And we can tell when somebody's muscles turned on and when it's turned off. We can tell how fatigued they get because we can see the contraction rate drop when they're doing exercise, so we can tell them when they get fatigued. So these things are really useful for assessing when a player's tired or needs recovery or something like that.
Also, it's for prevention.
Yeah, definitely. Yeah.
So you won't get exhausted
Yep.
and overwork your muscles.
Yeah, yeah. But also it's for training as well. So like, if I want to increase the strength of my muscle and see there's a difference between pre and post training. So that's contracting the biceps. When I'm holding the contraction and see I can hold it as long as I can, and then it's starting to get difficult, and then relax. And then the other one, the triceps, contracting the triceps, and you see the biceps are contracting as well, the blue line now, and then take that off like that, it stops. And you can put these all over your body. We get actual raw data and we can do the analysis ourselves. Yeah, this is a very accurate system.
Yeah.
We don't charge the athletes, we use them for our research subjects. We have data security and data privacy.
We're using these IMUs to measure knee angles in athletes. More specifically, I'm using them for measuring knee angles in ACL injured persons. So what I'm doing is that bringing males football players and asking them to do directional change. So they will run and then cut to the left and right. And what this measures is the risk of ACL injury. And we're using also the virtual reality to simulate real-time scenarios of football. So I programmed these VR to measure his knee angles at this moment.